Bismillah ar-Rahman ar-Rahim. Our guests, invited speakers, presenters, and colleagues. Assalamu alaikum wa rahmatullahi wa barakatuh. After the successful first day, it's our honor to start the second day of the second International Conference on Environmental Sciences, Engineering, and Sustainable Development. Our objective here today is to continue discussing about the environmental problems and to offer the engineering solutions to participate in the efforts aimed at achieving the goals of sustainable development and the Oman Vision 2040, in accordance with the directives of Sultan Haytham bin Saeed, Hafidhahullah wa Ra'ah, in addition to achieving the vision and mission of the University of Technology and Applied Sciences to achieve scientific leadership. Let's begin by addressing the first item on our agenda for today, the first plenary talk, which will be given by Dr. Eni Oko, Associate Professor in Chemical Engineering at Newcastle University. Dr. Eni is going to discuss about the ammonia as a suitable hydrogen carrier. I would highlight here that the questions for our three keynote speakers will be at the end of this session in a round table discussion. Dr. Eni, the floor is yours.
Assalamu alaikum. Thank you so much for having me here today. And I want to thank the organizers of the conference, Dr. Khalud, Dr. Wasil, and everybody that have helped make this conference a reality. And thank you so much for inviting me. I have had absolute good time here in Oman. It's been a good experience for me. Last night, I was chatting with my family, and we already decided we are going to come on holidays in Oman, so thank you so much. Today, I'm going to be giving a presentation on ammonia to hydrogen system, slight change in the title, for industrial cluster decarbonization. My name is Eni Oko, and I'm from Newcastle University in the UK. Yeah, so Newcastle is located close to the Scottish border in England, and we are located just right close to one of the industrial clusters in the UK that's called the Teesside Industrial Cluster, which is, how to say? Yeah, which is what you can. This is the Teesside Industrial Cluster, and this is another industrial cluster called the Humber Cluster, and there are quite a lot of industries that are located around here. Yeah, so in terms of my research, I'm a process systems engineer, and what that means in principle is that I use computational approaches in my research. So my research is in the area of carbon capture, hydrogen, biogas production, energy systems analysis and integration, and then lastly, computational material design, which is catalyst design, adsorbent designs, etc. Here is a lineup of some of the research that we'll have, some of the research projects we've had in the last couple of years. And today specifically, my presentation is drawn from one of the research projects that we have just concluded, not concluded actually, it's been extended, and it's still ongoing on the feasibility of ammonia to hydrogen network in the Humber cluster. The Humber cluster is one of the industrial clusters in the UK, and this project has been done with University of Hull, University of Wolverhampton, a company called Drax, and another organization called HICP. That's just some of the CO2 capture projects that we have also completed in the last couple of years. So today I'm going to talk you through a background, highlight some of the CO2 hydrogen storage options, discussions around ammonia as a hydrogen carrier, and of course some model developments and results that we've done. And I can also give you some highlights on the R&D landscape in this area. So we start off this talk by talking about the hard-to-abate sectors. The hard-to-abate sectors are essentially the sectors that are difficult to decarbonize. One of these sectors is the transportation sector. The transportation sector is extremely difficult to decarbonize for a number of reasons. The other one is domestic heating, although it may not apply to Oman, but in many cold countries where you have to heat your home, you burn a lot of gas to do that. Then, of course, industries, and even in some cases, power generation. These sectors contribute a large share of emissions globally. And if we can ever meet decarbonization targets, these sectors must be decarbonized. One way to do that is the development of low-carbon storable fuel, right? Which is safe, efficient, and cost-effective. Right, so the IEA Blue Map scenario looks at the portfolio of options that can be used for decarbonization across different sectors. The Blue Map scenario looks at two scenarios. The first one being the 2-degree scenario, which is the sort of technology options that can be deployed and to what extent in decarbonizing, in achieving the 2-degree target. The Paris Agreement looks at beyond 2 degrees. And for beyond 2 degrees scenario, the estimate is that fuel switching, which will include replacing fossil fuels that is currently used across the various sectors with a low-carbon fuel type. So you can see that fuel switching is expected to contribute as much as 18% in achieving decarbonization targets between now and 2060. And then we talk about hydrogen. Hydrogen has become very popular because more and more we have many countries keying into the reality that hydrogen could be a vital fuel option for meeting decarbonization targets. Following up with that, many countries now have hydrogen strategy in place, including Oman. And the figure here just highlights some of the figure here highlights, I don't know. The figure here highlights some of the various activities on hydrogen across different countries. So you can see Oman somewhere at the center, and this figure was extracted from a report that was prepared like 2 years ago. And it's interesting that Oman is considered as one of the countries that are leading the way as far as hydrogen use is concerned. There are quite a number of projects related to hydrogen across the world, mostly in Europe, but you can see that the various regions globally are represented. All right, so globally there is around public funding commitment in excess of 37 billion to date. All right, most of the conceived projects, some of them in planning and some of them ongoing, are mostly targeted at production, okay? And just a little portion of it is targeted at hydrogen transport, all right? Then in terms of hydrogen, using the UK as an example, so with expected adoption of hydrogen across the UK, it's expected that by 2050, you are going to have between 20 to 25% of the final energy use in UK coming from hydrogen, all right? So this kind of paints the background of what's expected as far as the hydrogen landscape is concerned, all right? So if the UK is going to be using around 35% of hydrogen, the facts on ground are that a good proportion of hydrogen in the UK, for instance, and many European countries, is very likely to be imported, all right? And of course, this market between now and 2050 is likely to be dominated by hydrogen, blue hydrogen, essentially. And that is for a number of reasons. This blue hydrogen is expected to be imported. The prospect of producing hydrogen, blue hydrogen locally in the UK doesn't look very promising because in the last 2 years, the cost of doing so have already gone up by around 36%, as you can see on the chart on the left. Okay, so it's going up very high, whereas for that of the imported blue hydrogen, it's relatively cheaper. All right, so in terms of hydrogen imports, all right, so obviously that's going to involve long distance transport of hydrogen from, for instance, the Middle East all the way to Europe, okay? So this figure here highlights the cost of transporting liquid hydrogen versus the cost of transporting LNG, liquid hydrogen, ammonia, methanol, and dimethyl ether, all right? So you can see that the cost of transporting hydrogen is significantly higher, okay? Significantly higher. If you compare that to ammonia, that's around 3 times the cost of doing the shipping. And the reason for that is mainly down to the very high boil-off rate that is associated with liquid hydrogen, all right? So what that essentially means is that when you are transporting liquid hydrogen, because hydrogen is not very stable, a good portion of it is likely to evaporate in port. And so you have to reliquify that component. You are not going to let it go, all right? You are going to reliquify that component and then turn it back to liquid, essentially. If you compare the boil-off rate that is associated with, say, LNG, ammonia, and hydrogen, you can see in volume percent, that of LNG is very tiny, that of ammonia also tiny, but that of hydrogen could be as high as 5 volume percent, which is substantial, okay? So this is essentially what is driving the cost that is associated with hydrogen transport. Obviously, the other fact which have not been highlighted here is that hydrogen have very, very tiny volumetric density, and because of that, if you were to transport hydrogen with the same amount of energy as, say, diesel, for instance, you will require significantly bigger shipping vessel, you know, to be able to transport them. Not sure, this is not working very well. Yeah, so in terms of hydrogen transport also, the other point, hydrogen can be transported in different forms, and one of them being compressed hydrogen. And compressed hydrogen is extremely expensive, and because the systems can be sized for pressures up to 900 bar. Why you need to transport at extremely high pressure that way is that, as I've mentioned, the volumetric density of hydrogen is very low. So you can see you are talking about around 40 grams per liter at 700 bar, all right? So if you are transporting at a lower pressure, then it's even going to be smaller. I have a figure that tries to compare the storage density of hydrogen with other fuel. The DOE estimate is that to store a kg of hydrogen at this kind of condition will be costing over $500 per kg, which is just very expensive. The other way to transport hydrogen is to transport hydrogen as liquid hydrogen. As liquid hydrogen, you transport hydrogen at a cryogenic temperature of around minus 253 degrees C. Again, this is very expensive, and as you can see from this figure, this is a concept liquid hydrogen storage tank from Linde Engineering in Germany, and you can see how, just by looking at it, how complicated it looks. But interestingly, transporting hydrogen as a liquid is way more cheaper compared to transporting hydrogen as a compressed vessel, as a compressed gas. Then, of course, apart from that, we also have other things to consider, which will include things like safety. As a compressed gas, hydrogen is likely to embrittle steel materials, which means if we are going to build hydrogen transport system, you need a special material that is not necessarily steel. You are talking about carbon fiber reinforced material. This type of materials are extremely expensive, and they are very, very energy intensive to manufacture. Then the other point which I have mentioned is low volumetric energy density for hydrogen. If you look at this figure here, you see that in terms of the volumetric density, which is on the horizontal axis, you see that the volumetric energy density of hydrogen is way higher than the volumetric energy density of other fuels, other common fuels. But where the problem is when you are now looking at the volumetric energy density. This is very, very important because this is what you will use to estimate the required volume of storage tanks, for instance, that you will need to transport hydrogen. Now, if you take a look at this, this portion of the graph, you would see that if you take a look at this portion, that portion of the graph, you will see that for instance, liquid hydrogen, the storage density is around 2 in kilowatt-hour per liter. Now, if you compare that with, say, diesel, you see that the storage density is around 10. What that means in principle is that to transport the same amount of hydrogen that you would get with a given quantity of diesel, you would require roughly 5 times the storage tank. So imagine that in your car have a 60-liter diesel tank, for instance, and then you wanted to replace that with hydrogen to achieve the same mileage, okay, in terms of how far the vehicle can go with a full tank, all right, achieve the same mileage, achieve the same kind of speed, etc. You would require 5 times the volume of fuel tank that you currently have in your vehicle, and that's where the problem starts. And this is also the problem of building hydrogen-fueled vehicle. We have a case study that we did for aircraft, which I will share with you today. All right, so that's the problem of building hydrogen-fueled vehicles, because if you have hydrogen-fueled vehicle, you'll find that because the storage capacity required is much more higher, what it will mean is that for the same vehicle to give you the same mileage, to give you the same speed, etc., the boot space, even the passenger compartment, will essentially all be part of the fuel tank in principle. All right, so which is kind of nonsense. Okay, so that's some of the research challenges that you can be looking to address, and this is why hydrogen carriers, as they are called, has become increasingly of interest, okay, in research. People must find alternative ways of, carrying hydrogen, either in onboard applications, in vehicles, in aircraft, in marine vessels, or for international shipments. All right, so in terms of hydrogen storage options, they are broadly classified into, you have the adsorbent kind of materials. The adsorbent kind of materials are They are mostly upcoming at the moment, but the best of them still operates at very low temperature, okay? The best of them still operates at very low temperature, which poses some problem, but it's something to think about if you have interest in hydrogen storage and transport. The other class of materials include the unsaturated liquid hydrocarbons like formic acid and the rest of them. The problem with this class of storage materials is that relatively, for the best of them, the hydrogen storage capacity is relatively low, less than 10 weight%. And of course, the reactors are complicated to design and they have high energy requirements, etc. Then you have chemical storage that includes ammonia, metal hydrides, and methanol. Ammonia is very popular for this application because ammonia have high hydrogen storage capacity. Of course, it also have high volumetric hydrogen density, which is around 1.5 times when you compare it to hydrogen itself. We can also do that at relatively milder conditions. So we can transport ammonia at, say, pressures as low as 10 bar. And then lastly, there is a lot of experience with transporting ammonia in the industry. Okay, so still talking about that, it is believed that global hydrogen trades, okay, is going to be mainly through derivatives. In other words, the derivatives here being the storage materials. And ammonia is expected to make up at least 45% of global hydrogen trades. This is McKinsey report 2022. If you look at this figure here, you would find that if you compare ammonia performance in terms of hydrogen density with a good number of storage materials, you can see that ammonia is way ahead others. Then the other question that people will also be asking is the energy that you will require to convert ammonia back to hydrogen. Again, when you compare that with a good number of materials for hydrogen storage, you can also see that ammonia is much better than a good number of other materials. Then in terms of, sorry, this is a bit tiny, but I have put in this slide to highlight to you that the infrastructure for transporting ammonia is already in existence in many countries. In fact, in the US, there is in the region of 5,000 kilometers of pipeline that transport around 2 million tons of ammonia, annually. In Russia, you have over 2,000 kilometers of pipeline transporting ammonia within and outside Russia. So there's quite a lot of infrastructure. When I was also reading up last night, your country, Oman also exports ammonia, and the transport vessels for doing so are all in place. So you are not going to be inventing new technologies, to be able to transport ammonia. At the other end of ammonia transport is ammonia cracking or ammonia decomposition. You need to break down the ammonia to produce hydrogen. And in the UK, a company called AFC Energy is already leading the way. Sometimes last year, they completed several hours of trial for an ammonia cracking system, ammonia cracking pilot, that was producing around 400 kg of hydrogen per day. This pilot uses packed bed reactors and PSA-based hydrogen purification system. I'll talk about that in a bit. And then, of course, the ammonia that was used for this trial came from the Netherlands. There is already an ammonia import site in the Rotterdam port in Netherlands. And interestingly, the ammonia that is being imported through that port comes from the Middle East region. This is what it looks like from the end of the receiving country. Okay, so from the end of the receiving country, for instance, the UK, you have ammonia arrive at the port, and two two options are being considered. When you have ammonia come at the port, you have a massive facility that can be used to convert the ammonia to hydrogen, a bit like LNG transport, where you build the receiving port and then revaporize the LNG. So in this case, we break down the ammonia to produce hydrogen, and the hydrogen can then be piped to the various end users. This presentation is about a different way of doing that, which is a decentralized model. And this is particularly suitable for industrial clusters. Industrial clusters means that you have all the big companies in one place, most times, as it is the case in the UK, very close to the port or not very far away from the port. So the idea is that the ammonia that you are going to be receiving, instead of cracking it centrally and then supplying hydrogen, that we could essentially have smaller cracking systems. So if we have 5 companies, each of these 5 companies, you will locate a cracking system within their facilities. This idea is beneficial for a number of reasons. One of them is that most of the heavy industries that we target in these applications are already industries that produce a lot of waste heat. So imagine, for instance, a steel complex. Imagine, for instance, a refinery, etc. These are companies that traditionally produce a lot of waste heat. So if we locate an ammonia cracking system within their facilities, that means that there will be increased potential for heat integration, which could help minimize the primary energy use. The other point is flexibility, okay? And flexibility is very, very important because at the start of the technology deployment, you will find that not everybody is going to sign up for it. So let us say, for instance, you are targeting an industrial cluster that have 10 companies. But at the start of the project, you find that it's only one company that have come forward to take up this technology, all right? So look at the first scenario where you have a massive central system to supply this hydrogen. But then the central cracking facility that you will build at the start of the project, are you going to build it for the 10 companies? Which wouldn't make sense, since it's only one company that is willing to be taking hydrogen from you. The other interesting fact will be, okay, but if you build a smaller pilot system, that would mean that it will enable you to phase the rollout. So it allows a phased rollout, which is very likely what is going to be the case in the future. So if you have 10 companies and the first one signs up in the first year, and after 2-3 years, another company signs up. So you can gradually roll them out in phases that way. So without needing to rebuild the plant or do something of that sort. Okay, so, and that is why most of the work I do currently is focused on the decentralized ammonia transport model. So this presentation is really about what happens from the time that the ammonia arrives at the port of the receiving country and how that can then turn to energy in terms of supply to the various people that need it, focusing mainly on industrial users. All right, so in the UK, we have the main companies in UK are organized in clusters. And here are the main clusters that we have around the UK. We have one that is called Grangemouth Cluster, which is located up in Scotland. We have Teesside, which is close to where I am. And then we have the Humber, which is, so we have the Humber, which is where my presentation is going to focus on. And then, of course, we have the one in Wales, down in Southampton, the Black Country, Birmingham area, etc. The Humber is very special in the UK because like 3 out of the 6 refineries in the UK are located in this region. And then, of course, you also have what they call the Sleipner Pipeline project, which is actually an underwater pipeline that connects the UK from Norway, and around 40% of the gas that we use in UK actually comes to the UK through this pipeline. So this is part of the reasons that makes this region, the Humber region, a very special region in the UK, okay? And so you have all the big factories around there, and that's why my work is focused mostly around there. So this is just an instance of what I have been talking about. Around here is a small village called Immingham, and in this small village we have a port that is operated by the Associated British Ports, and in association with a company called Air Products UK, there is a plan to establish an ammonia import site around here, all right? And the initial assessment that we have done has looked at, okay, when you receive the ammonia, and we'll build this conceptual pipeline. Remember, this pipeline doesn't exist, okay, yet. So we'll build this conceptual pipeline targeting the various companies that have been shown on this figure. So you have a company called Drax, which is a power plant. And then you have the refineries, Lindsay Refinery. This is also a refinery. And this is also a refinery. You have some upcoming plants too. We'll have the Kidby, which is power plant, and we'll have Scontub Steel, which is a steel complex. And the more interesting of them all is what we call the Salt End Park. The Salt End Park is a chemical park that have very many chemical companies located in that site, including the BP Chemicals. All right, so this is a conceptual map that we've created that has informed most of the analysis that we've been doing in this area. And we're looking to, we've just completed the design, and we are now at the techno-economic analysis and life cycle assessment stage for this project. And of course, building from what Air Products and ABP are already doing in the sites. All right, so some of the key things to highlight here is that a big issue is the ammonia tracking system. And ammonia cracking is a highly endothermic reaction for non-chemical engineers. That essentially means you need to put in a lot of energy to be able to, for ammonia cracking to happen, essentially. But that is not the only problem. The other problem is that ammonia cracking is an equilibrium reaction, okay? So you have ammonia breaking down on one hand and forming hydrogen and nitrogen on the other hand. Now, the problem is that this reaction is equilibrium limited. What that means is that as the ammonia is breaking down to form nitrogen and hydrogen, the nitrogen and hydrogen will tend to start recombining, okay, to form ammonia, all right? This presents a lot of challenge with the reactor development, and I will talk about that in a bit. Then US DOE have done some analysis, and their analysis suggests that to have, for this system to be very competitive, that we need to develop catalysts and reactors that can deliver acceptable efficiency under 400 degrees C. And this is where the problem is. All right? So as part of our work, an aspect of our work is focused mostly on the reactor development end of it. All right, so initially we did some assessments, we did some models, and here is a result that we developed from the model, which highlights the existence of equilibrium limitation within the reactor. The problem with that is that it makes it very difficult to achieve, say, 90% conversion, for instance. In other words, 90% of the ammonia that you're putting into the reactor is converted, is completely decomposed. It's very, very difficult to achieve that when you are using tubular reactor design. Okay? Then we also looked at different technologies that can be used to make this happen. We started off with, we did some assessment, looked at what has been done already on electrochemical decomposition method. We also looked at photocatalytic routes, and each of them have their limitations. The electrochemical decomposition method uses very expensive catalysts, and we didn't want to go there. We looked at photocatalytic route. Photocatalytic route, based on state-of-the-art catalyst, the conversion is extremely low that can be achieved with photocatalytic cracking. We looked at the plasma-assisted route, and the plasma-assisted route works mainly for small-scale kind of reactors. This is potentially promising, but again, the operating temperature for most of the catalyst is way over 600 degrees C. Our target from get-go has been looking at a technology that can be used to deliver a good conversion under 400 degrees C. Then we looked at microwave heating. Okay, so using microwave to provide the source of heat. This is very good. Temperature is not so bad. Conversion is extremely good. Catalyst is relatively cheap. The problem with microwave heating, however, is that it's extremely difficult to scale it up. So the microwave you have in your kitchen, to be able to scale it and use it in the industry, it's very challenging. And this is partly because temperature measurements with microwave heating is very difficult and challenging. And apart from being challenging, heat distribution is also usually poor with microwave heating. Then we looked at pyrolysis. The conversion, the temperature is extremely high. This is thermal cracking without any form of catalyst. Temperature is very high. Technology is relatively mature though, but the temperature for doing so is extremely high, and it's outside what we can do. And lastly, we looked at thermal catalytic cracking, TCC, which is where we are focused on mostly. Currently, there have been catalysts that have been tested with good performance at around 450 degrees C. Some of the catalysts are relatively cheap. The technology is also relatively more matured. So most of our work has been focused on thermal catalytic cracking. So we identified what I'll call the research challenge in this area, in thermal catalytic cracking development, and it's something to take on board if you have interest in this area. Now, the first part of the problem is in the catalyst, okay? Currently, what they are using are ruthenium-based catalysts. Ruthenium is extremely expensive, and in the European Union, they categorize ruthenium as a critical raw material, all right? And they encourage people to look at developments that does not use this type of material, essentially. And there is a new class of catalyst that is emerging. It's called the lithium imide catalytic class. These are relatively cheaper to produce, but however, the problem with them is they are not compatible with very many catalytic support. So if you are interested in this area, one thing to look at could be new catalyst support for this type of catalyst. Then the last area of challenge is the reactor design. From the reality of equilibrium limitation, the new types of reactors to be developed must look at reactor design, all right? Reactor design that integrates hydrogen separation within the reactor. So you have a hydrogen separator and a reactor all integrated as one unit. Why this is important is because of equilibrium limitation. We want a situation where the hydrogen can be taken out of the system as they are formed, right? All right, so a good part of our research, as I've mentioned, part of the things that we do is using computational methods to design catalysts. And we've used some of this application to assess, to kind of develop a methodology, a simple methodology that we can be using to assess different catalysts. Now, this simple methodology, what we do is to simply estimate the energy barrier, because for a start, a key criteria for assessing catalyst suitability for us is the energy barrier associated with the catalyst in ammonia cracking. So what the method that we are using at the moment does is to estimate the transition state associated with specific catalyst in this process. So the transition state looks like this for non-chemical engineers, and with the transition state we can compare, we'll be able to estimate the activation energy. All right, so if we can do that for different catalysts, we can then use that as basis to compare which one is accepted or not. Of course, after doing this, this still needs to go forward to the lab, where you will then synthesize the catalyst and, of course, test the catalyst for different properties. But this helps you make some quick decisions, all right, without needing to go to the lab from day one. All right, and this is what the methodology looks like in principle, how it works. We work out the geometry. This is done at molecular scale. Work out the geometry of the scan, do some potential energy surface scan, etc. And based on that, we'll be able to identify the transitions, identify and optimize this transition state associated with the particular system. This method of modeling is based on density functional theory, okay? And currently we are using a software that's called ADF. There are softwares that you can use to do this that are completely free, which you can download and use straight up from the internet. And so from this type of analysis, we've built some stuff like this, and you can see some of the transition state estimates for different materials that we have considered. So at the end of the day, you have a result like this, and this particular one is for ruthenium-based catalyst. So for ruthenium-based catalyst, considering different supports, we can see the energy barriers that is associated with the various options. So from what I was explaining, by looking at this, you see that the ruthenium catalyst on alumina support for this specific comparison is likely going to achieve our target of operating at a lower temperature than a ruthenium-based catalyst that is using magnesium hydroxide support, for instance. Okay, so that's the point of the computational study that we are doing. And the ruthenium-based catalyst in this particular example we can then go ahead to do the synthesis in the lab. Now, what we are doing currently is, having established this method, we can then use can now apply it to other non-noble metal catalysts. All right, I'll run it off now. And we looked at reactor design, tubular reactors, which requires downstream separation. And we also looked at catalytic membrane reactor, which essentially integrates separation within the reactor, okay? All right, so we did some model development using a software called Aspen Custom Modeler, and where you build the code from scratch yourself and the rest of them. So here are some results which shows this was very promising. The other thing that we looked at is onboard application of ammonia cracking. And, you know, as I was explaining earlier, carrying hydrogen on board is quite a challenge, and we are looking at, you know, replacing that. And we've done some analysis. There's quite a lot of study in this area, and everybody is saying, okay, it's focused on mostly on the engine development, you know, essentially. So what our studies has done is to look at, you know, the storage capacities, you know, for that. So we did that, and we used the A380, the very big Airbus aircraft, to do this analysis and try to estimate what will be required. And part of the things that we have found is that in terms of volume ratio, you are looking at around 2.65 in terms of volume ratio compared to the Jet A fuels that are currently in use. What this means in principle is that the volume of fuel that you carry on board when you are using the traditional fuel, you will need around 2.65 percent of it if you are going to replace that with ammonia. That's not all the problem. The other problem that we found is that because we expect that the ammonia is going to be transported at low temperature, at around 10 bar, currently the A380, the big aircraft, in case you don't know, the the fuel tank is usually on the wings, all right, for the big aircraft. The fuel tank is usually on the wing. Now, the problem is that if we are going to be pressurizing the system to 10 bar, it cannot, the wings are not built to support that kind of pressure. What then that will mean is that if we're going to have an aircraft that looks like A380 as it is today, that the fuel tank will have to be carried within the aircraft body. That means that you will sacrifice a lot of payload, if you wanted to fit this in. All right, so there's quite a lot of activities that are going on in this area. So if you are working in this area, you are absolutely not alone, and there are lots of industries with interest in developing ammonia cracking system. And this is just a highlight summary of what we're doing. Hydrogen is possible viable for decarbonizing industries. Ammonia to hydrogen approach is essentially important to help mitigate the challenges with hydrogen transport and storage and transport. But the biggest challenges remains developing non-noble metal catalyst, which is what we are doing at the moment, developing novel membrane reactor design to support ammonia cracking, etc. Quite a bit of shout outs to the various organizations that have been funding my work. And thank you so much for having me. I can go? Okay, after. Thank you.
Thank you, Dr. Eni, for sharing these valuable insights. Our next keynote speaker is Professor Dr. Khalifa Al-Jabri, a professor in Department of Civil and Architectural Engineering at Sultan Qaboos University. Today, Professor Khalifa will be talking about wastes as a sustainable construction material. Professor Khalifa, the floor is yours.
بسم الله الرحمن الرحيم. السلام عليكم. صبحكم الله بالخير. My friends, colleagues, ladies and gentlemen, it's always good to be at your home village. So I am very pleased to be with you today, and I would like to thank my friend Dr. Wasal and the organizing committee for giving me this opportunity to come today and to talk about this topic. Actually, when I finished my PhD in 2000, my research topic was different, totally different from this topic. I studied the behavior of beam to column connections, steel, beam and composite column connections in fire. And at that time, the structural fire engineering is one of the emerging fields of study. But when I came to Oman, and unfortunately, all the resources to continue my research in the same field was not available. And therefore, I asked my colleagues, what are you doing? And they said, we do some research in recycling of waste materials. At that time, in 2000, about 24 years ago, the waste generation was not as much as now. And with the development in the construction industry, and also in the industry in Oman, we have, mashallah, we have seen that we had a great development in the industrial activities in Oman, and especially in Sohar, where we have Sohar port and the free zone, where there is a lot of petrochemicals factories. We have other types of factories, steel factories, chromium factories, and therefore the industrial wastes are generating and accumulating, causing a lot of actually environmental problems. And therefore, we started in 2000 to work on the use of these materials in construction and also in civil engineering applications. And in actual fact, when we talk about the industrialization and the construction industry, it contributes to between 15 to 45% of the total environmental deteriorations. And this is include the use of raw material. Here in Oman, we are using actually the raw material we have. We don't have a problem with the raw material we use in the construction industry. We have a lot of quarries, a lot of mountains. We have Gabro. We have, in the northern of Oman, we have also other kind of materials, the clays, and therefore we don't have a problem with the material. But we are depleting our environment. We are consuming our environment, and therefore I am afraid in the future we will not find enough material for construction. And therefore we need to be careful and we need to be cautious. Also in terms of energy use, we use a lot of energy to produce cement, and therefore producing cement needs energy. It will produce CO2, and 1 ton of cement produces 1 ton of equivalent CO2. And this is also a problem. Also, the use of fresh water. We cannot use recycled water, treated water in the production of concrete or other materials. We need to use potable water, clean water, and therefore this is a problem. Also, we are consuming a lot of water. And also we have atmospheric emissions. The greenhouse gases are generating at an alarming rate, and this is causing a problem, causing global warming, and the global warming will cause the increase of natural disasters. We have seen in the recent years, we have the magnitude and the frequency of cyclones has increased in Oman. We have since 2007 to 2020, we had about 4 cyclones which hit the coast of Oman. And these are contributing to the main contributor is what they are saying is the global warming. And also we have the increase of and frequency of the flash floods. And we have seen the wadis and the flash floods which are generating and causing destruction to the infrastructure and also the loss of lives and economy. And therefore, we use concrete in Oman for the buildings. The main material we use is concrete. And worldwide, the annual concrete consumption is 25 billion tons per year. And this is expected to increase by 12 to 23% by 2050. And also the construction industry is the main contributor to the CO2 emission, CO2 footprints, which is accounts about 8% of the global CO2 emission. And therefore, we need to find an alternative materials to be used, and either to use it as a replacement of sand, of aggregates. These are the ingredient materials, or it can be used as a replacement or supplementary materials in the production of cement. We need to reduce the amount of cement we are using in the construction industry. And therefore, even after construction, some people, they don't realize, even after the construction, still our buildings is emitting CO2. Because the hydration process is a continuous process. The reaction between water and concrete, it is not like a short-term process. No, it is a long-term process. And therefore, the buildings are continuing emitting CO2, even after construction. And therefore, we need to find alternative ways, alternative sources. And one of these ways is the use of waste and industrial byproducts. Waste generated from industry, the byproducts which are generated, also have properties which is similar to the either to the sand or to the concrete, and therefore it can be used. It has potential to be used as a construction material, and therefore it will reduce the consumption of our natural resources, and also it will, if we use it as cement replacement or we use it in the production of cement, they can contribute to reduction in the CO2 footprints. And therefore, when we investigate the benefits of using alternative materials in achieving the Sustainable Development Goals, we know that United Nations has launched the United Nations Sustainable Development Goals, and there are 17 goals for sustainable developments. And therefore, when we use alternative materials in reducing the energy used and carbon footprints, so we fulfill the goal number 6 in the United Nations goals. And when we use it as sustainable consumption and in the production of concrete or mortars, we fulfill the goal number 12 on the United Nations. This one, the Sustainable Development Goals. And therefore, in recent years, we had these terms, we hear these terms, green concrete, sustainable concrete, and all these, and therefore, when we produce, what's the meaning of producing sustainable concrete, for example? We use other materials rather than natural sand or natural aggregates in the construction or in the production of concrete. And therefore also we can use other materials as cement replacement, and therefore we can have a lot of benefits out of producing sustainable concrete. We can have energy efficient material. We can have buildings with enhanced properties and so forth. So this diagram shows the benefits when we use sustainable or green concrete. And therefore, when we talk about the production of concrete, we need to be careful. We need to know all the properties of the materials, either in terms of preparation or in terms of the selection of the right materials. And also, we need to carry out the material characterization. We need to know the chemical properties of the material we are using. We need to know the physical properties of the material. And therefore, we need to make sure that the material is suitable to produce the required sustainable concrete. And therefore, after we produce the concrete, we have so many properties we need to discuss, we need to know. We need to know the properties of the fresh concrete in terms of the workability, flowability, consistency, setting time. So all these are important properties. And also we need to know the properties of hardened concrete. And these in terms of the mechanical properties, like strength, modulus of elasticity, shrinkage. All these are some of the properties. And also one of the important parameters is the durability. Sometimes we concentrate on the mechanical properties and we forget the durability of concrete. And this can be measured by so many tests, by the water permeability. We need to see the carbonation. We need to see the chloride ingress. We need to see also the carbonation, drying and wetting properties. And if we are in a cold country, we need to know also the thawing, freezing and thawing behavior. So all these are important parameters and factors we need to consider when we produce the concrete. And this shows the itinerary diagram for the chemical compositions of the material of cement. Cement, the main composition of cement consists of the oxides. And basically we have 4 oxides. We have the lime, calcium oxide, and this is very important parameter. And we have other oxides, like we have silica, and we have aluminum oxide, and we have ferrite, the iron oxide. And if we classify the material, different materials can be classified chemically within this triangle. And therefore, if we have a material which is rich in these 3 silica, which is the iron, aluminum, and silicon, this means that this material has a pozzolanic reactivity. Pozzolanic reactivity, this material can be used as cementitious material if we give it an activator. We activate it with other material. And if we go to the bottom of the diagram, here we have these kind of materials are rich in CaO, calcium oxide, and therefore these materials has the potential to be reactive with water, and it can also replace the cement. So chemically, when we classify these materials, we need to take care of these substances. These are the most 4 oxides that we need to consider. Of course, we have other elements that we need to consider. For example, if we have the material is rich in sodium oxide or in potassium oxide, this is not good for concrete. This will activate, these are called alkalis, and this will activate the alkali silica reaction, and therefore the concrete will deteriorate. It will crack after some period of time. And therefore we need to be careful. We need to study this material in depth. So actually we use different types of waste materials. The use of waste materials in concrete as sustainable is not a new thing. We use, for example, fly ash. Fly ash is waste material. We use silica fume. Silica fume is used in the production of high-performance concrete. Silica fume is considered as a waste material, but now it is used in the construction industry. We use also the granulated blast furnace slag, and this is also an important material. So the use of waste material is not a new issue. It is an old issue. But recently we had also a new waste which are generated. We have steel slag, we have ferrochrome slag, we have different kinds, copper slag, different kinds of slags and materials, either domestic wastes or industrial wastes. And actually these, if we don't find a way to use these materials, they will end at the dumping sites. And also we need to be careful. We have a lot of illegal dumping sites. If you move around here and in Oman, for example, you will see a lot of illegal demolition waste which has been dumped in the wadis, for example. This is illegal. The people, they come at night, they dump all these waste materials, creating a lot of environmental problems. And therefore, we need to find an alternative solution for these problems. Actually, myself and my team, we studied the industrial waste and bioproducts, as I said, a long time back. And about 4 years ago, we had a project with Sohar Port and Free Zone and other factories here in Oman to study the potential use of 2 materials, the steel slag and ferrochrome slag. Ferrochrome slag is a byproduct, and in Oman is considered as a waste. You cannot use it. And it comes after as a secondary material after the production of chromium. And here in Sohar, we have Gulf Mining, we have Attaman. These are, and other, I think, factories, these are responsible for the production of ferrochrome slag. And we have also other factories like Jindal Shadid, Sohar Steel, producing steel as well. And therefore, there's accumulation of these wastes. You see in Oman, the amount of ferrochrome slag production is about 0.35 million tons per year. And this is not a small amount. And so this is the sum of the waste production in Oman. And you can see the ferrochrome slag production. And you can see these are not piles of aggregates. These are piles of ferrochrome slag, which are considered as a waste material. You cannot use it. You dump it there without any further reuse, because this is in Oman is classified as a waste material. You cannot also transport it or export it to other countries, because Geneva Convention is preventing or prohibiting any transfer of any material which is considered as a waste across borders. And therefore, this is accumulation. This is the problem. And therefore, we need to find an alternative for these materials. The experience of other countries, these materials are used in different applications. In concrete, for example, and also most widely used in the road constructions, in the hot asphalt as aggregates, in the base and sub-base of roads. And therefore, they have applications. And therefore, it's very important to use and to take advantage from the properties of these materials and use them in the construction industry. So we did a lot of work, and we had this project for 2 years to study the potential use of ferrochrome slag and steel slag as a construction and civil engineering applications. And we concluded the study, and based on our study, the Ministry of Commerce and Industry and also the Environment Authority changed the classification of these materials from wastes to byproducts. And therefore, now these materials can be used in other applications or can be transported to other countries for further use. And then we continue our research after that project. And today I will give you some examples of the studies which we did. And we are still doing also on the use of ferrochrome slag. This is only one material. We are dealing with other materials. We are also continuing studying the steel slag. And also I have one of my PhD students. She is studying the waste marble. Also, waste marble is a problem in Oman, and therefore it has different properties, of course, from slag. And therefore, also one of my PhD students is working in this area. And therefore, this is the properties of the ferrochrome slag. Ferrochrome slag has large quantities or large concentrations of ammonia and silica, and also magnesium oxides. And magnesium oxides has the characteristics of high thermal conductivity. And therefore, when we produce concrete, the concrete will be has higher thermal conductivity than the normal concrete. But this is not an advantage always, because material with high thermal conductivity can be used in mass concreting. For example, in underwater concreting, in bridge abutments, in other mass concreting large areas. And this will control the hydration process, because the concrete production will be associated with liberation of heat, and sometimes heat could be intense, and this could produce thermal cracks in the concrete. So these are the properties of the ferrochrome slag, and you can see the ferrochrome slag is similar to our normal aggregates. The properties are quite similar, and therefore we use it mostly as replacement of aggregates, not replacements of cement. And these are some studies, of course, I talked about this, about the chemical composition. And therefore, we need to study the physical properties of the material. The physical properties include the fineness, specific gravity, water absorption. All these are important characteristics also we need to consider. And therefore, we find that the water absorption is ranked between 0.42 and 2%, which is almost comparable to the aggregates, and also the specific gravity is similar to aggregates, which is ranging from 2.63 to 3.21. And therefore, we studied two types of ferrochrome slag, and these from two different factories. And this is the grading. Also, you need to know the grading. The grading is very important, and therefore it will affect poorly graded material. It will affect the concrete properties. And this is the results of our study regarding in mortars, of course. And in the first material, we have noticed that when we increase the percentage of the slag, the compressive strength will be reduced. And this is due to the poor grading of the material. We use the material as received. And for the other source, we find that there is an improvement in the compressive strength. And also, in another study, we studied the behavior. We added only 20% as the sand replacement, and we find that there is good improvement in the compressive strength. And also, there is a great result, is very important. And therefore, if we have shrinkage concrete, it will result in cracks, and therefore the shrinkage is reducing as a result of increasing the percentage of ferrochrome slag. And also, as I said, the thermal conductivity will increase further. So then we studied the use of ferrochrome slag in concrete, and we find that this is the grading, and this is the comparison between the lower limit and the upper limit. And we find that there is good improvement also and reduction in the shrinkage, and there is good improvement in the compressive strength of concrete, and also in the modulus of elasticity. And then we study this behavior of the material at elevated temperatures, at high temperatures, and we heated the specimens up to 1,000 degrees Celsius. And also we find that the behavior is comparable to the normal concrete, and we compare the degradation of this material with the degradation of concrete properties for an EC2 European Code 2, and also the American Concrete Institute. And we found there is a good agreement, which is matching of the degradation properties of this material. And then we used in the application in the previous concrete. Previous concrete has very great infiltration rate, and it can be used in road applications. So we find that the strength is, density is okay, the compressive strength is good, comparable to the control mixture. And also we find that the infiltration rate is increasing with the increase of the ferrochrome content in the mix. And then also we use this one in the composite column. And this is, I came back to my original research when I talked about the behavior of steel in fire. So these are short columns, steel columns, which is filled with the ferrochrome slag as replacement of aggregates. And we studied this behavior at elevated temperatures. And we studied the failure mode of these stubs. And this is the stress strain. I will not go in details about the strain behavior. And these are the deformation. And you can see the deformation is very good compared to the control mixture. So these are some of the, and also we find that the degradation is actually better. You see, this is the, this is 100% replacement of ferrochrome slag, and this is the control mixture, and you can see the behavior of these in fire condition is much better. You see the degradation is less than the control mixture. And then we went deep into nano size, and we studied also the behavior of ferrochrome slag on the nano size, and also we used here the nano metakaolin. And this is clay, which is used as a sustainable material. And we can see there's a good improvement also in the strength, in the thermal conductivity. And also, my final remark here is we need to take care also of the environmental impact of these materials in the environment. And therefore, for ferrochrome slag, for example, we need to check the heavy metals. We need to conduct leachate tests for the raw material and also for the binder. We need to see if there's any leachate, if there's any heavy metals exist which cause harmful effect to the human beings. And also, we find that in ferrochrome slag, we have the chromium oxide, which is chromium 5. And this is a highly toxic material, but the concentration we find it is below the international limits. Now here we need to make sure that when we use such types of materials, we need to conduct the environmental impact assessment. And also we need to conduct what we call leachate tests in order to make sure that the material will not cause any harm to the environment or also to the people. Now my conclusion is that we can use industrial byproducts as a sustainable material in the construction industry, but we need to have further investigation regarding the durability of these materials. It's not well studied. We need also to carry out the environmental impact assessment. This is very important. And also we need to prepare or to develop specifications for the designers. Designer will be reluctant to use this material without any specifications. And therefore, it is very important to have specifications in order to make sure that the material can be used safely in the industry. This is my presentation. Thank you so much for your attention. And if there is any questions, this is my card. You can scan it.
Thank you, Professor Khalifa, for the great presentation. It's worth noting here that Prof. Dr. Khalifa Al-Jabri former member of State Council of Sultanate of Oman, has been received the Royal Commendation in the field of health in 2022. Such an honor to have you here today between us. Our last but not least keynote speaker is Dr. Yahya Al-Shamsi, the Dean of the College of Engineering and Technology at the University of Technology and Applied Sciences. Dr. Yahya is going to spot the light on the green buildings in Oman and the demand to develop the Omani Green Buildings Code. Dr. Yahya, the floor is yours.
Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, everyone. Thank you to UTAS Suhar for inviting me to deliver this presentation today. And I would like to thank you, all of you, for attending this conference. Hopefully, at the end of my presentation, I will be delivering something useful to everyone here and to the country. Regarding the topic of my presentation here today, it's, as it has been mentioned already, it's about delivering or the need for having green building codes. And within the slot of time allocated for me, I will be trying to make this presentation very simple and straightforward. I have not placed number of I didn't place introduction in this presentation because I believe that most of us knows what's the meaning of building and what's the meaning of green building. However, the term or the technical term green building need to be more elaboration and clarification for the society, for the scientist, and for the researcher. Because I believe that a green building is a building that has positive impact on the environment, and this is the general definition of a green building. And in other terms, it could be also mentioned as the building which has less negative impact on the environment. Further, the green building codes, I do believe it cannot be imported, and it needs to be created within the environment and the constraint of the area where it will be used. This is very simple introduction. Let me go through my presentation. I hope that it will be clear to you. This is the objective of this presentation. I will be going through the building construction industry in Oman and the history of this industry. Further, I will go through an exemplar of green building in Oman, which have been established by a number of universities in Oman. And then I will go through an energy rating tools that created by UTAS, and we are on the work on this tool ongoing. So I'll present for you these tools and how it can be used in the future, hopefully after testing and getting promising results out of it. This is the general statement for my presentation, that the absence of green building codes in the country led to considerable amount of usage of energy. And this amount of energy can be reduced dramatically if we have green building codes. From where I have absorbed this statement, as I mentioned earlier, there is a number of green building constructed in number of universities. I conducted a small review and research on those buildings, and I find out that the amount of energy consumed by this type of building is very less. What are the drivers? What are the drivers to have a green building codes? All of us probably have seen this graph several times in this conference and previous conferences and everywhere. And this graph, it shows you the increase in the temperature within the time scale, and compared to the pre-industry era. So all of us understand the concept of this graph and why it's happening. Further, all of us knows the adverse impact of this. Already, Professor Khalifa has mentioned that the number of cyclones in the recent time have been increased here in Oman due to this. Further, I want to show you the current status of our CO2 emissions. And the emissions, unfortunately, it is measured by a scale compared to per capita. It might not be that much accurate, or it might not be that much fair, because if the country has less number of population, then the scale will be higher and so on. But this is unfortunately the scale used in the global scale. And this is, it shows you the world or the global increase of emissions. Slightly you can see the increase, but if you compare to Oman, CO2 emissions, it's increasing very dramatically during the past 40 years. And all of us knows that because of the development happening in the country. Further, we need to use energy in the building due to the climate condition that we have. Probably now in the mid of summer, still in this building we are using air conditioning system. So the air conditioning system is working in most buildings in Oman for most of the time of the year, and that required a lot of energy. And this is the reason behind, because of our climate condition considered as warm desert climate for Oman and most of the Gulf countries. If you compare this area with the world, you can observe that these are the areas where there is harsh, I can say, climate condition, and that will require to modify the internal condition of the building for thermal comfort of people. Further, in associated with the previous slides, I will go through these slides a little bit faster because it's just only an introductory slides to show you the case. The energy consumption in the world also shown here, and you can see from the scale that, again, the area I have mentioned with the same area have more energy consumption, and this is, again, due to the use of conditioning system. Now, if you look at the energy consumption, or the, CO emission per capita in the worldwide and compare it to that area I have shown you already, you will find that Oman is fell in the 10th ranked and 5th in the area, in the Middle East. We'll go through the construction in, history in Oman, which lead to that increase of energy consumption and the climate condition of Oman. This is the previous, if you look at those two slides here, or those two photos, sorry, here, it shows you the ancient and previous construction industry we used to have. We used to have sustainable local material, which may not be, it still may require modification of internal climate of the building, but not as much as the concrete building that currently we are having. Further, this shows you the increase of energy consumption in buildings in Oman during the period, this period, the development period. And this curve shows you the annual temperature change. This is the mean, and this is the maximum temperature recorded, and this is the minimum for the city Muscat. And most of the cities in Oman are the same. We will look through the typology of buildings in Oman. We have, or they have been classified by researchers into main category, Arabic house, which is this one, and we have a villa, which is, this is another type, and we have houses, and we have apartment. And each one, in Oman, we are, or the population of Oman prefer to have villas in their type of residence. This is the increase of, these two graphs show you the, show you the increase. Let me go back to this one. It shows you the increase of the pyramids for building requirements from 2007 until 2014. We can see that the number of construction of buildings are increasing, and this is the number of increase of, and this is the required of increase in electricity developed in the country. Sorry if this graph do not appear properly, but you can observe that this big portion is 78%, and it is represent the HVAC system used in the building, and the other portion represent the other task at home which consume energy. Similarly, this graph shows you the electricity consumption in the country. It shows you around 40% or maybe more than 40% are consumed in residential building. In the building, sorry, in general. We'll go through this slide to show you the examples of the green building covered by this research. As I have mentioned earlier, there is a number of 5 buildings constructed in different universities and institutes, one of them in SQU, and this one in UTAS, which used to be at that time called HCT, and this is in Jutech, Dhofar, and Nizwa. Each building has been designed in different way, but designed in a such way that it will reduce the amount of energy required, and it will its impact on the environment will be less. Similarly, looking at the international scale, this building in California, and where it has similar climate condition and similar environment like Oman, and that building was also studied for the sake of this research. Now, looking at the barriers and solution in order to come over the issue of more energy consumption in the building, we have number of the barriers are classified into 4 categories, as you can see in this table, and what suggested solution for those barriers. One of them is the weather, like what I have said. Another one is the social, and one is economical and limited technology available. And those are the main barrier. Of course, there will be number of barriers, but this is the main classification of barrier. And the study comes through suggested solution in order to come for or to deliver green building construction in Oman. This is the consumption of electricity, or sorry, this is the price of electricity in number of countries. We can see that Oman fell in this area where the electricity prices are relatively low compared to other countries. Probably many people here still argue that the electricity prices are so high, but still it's, if you compare it to the international scale, it's relatively low. And probably this is one of the biggest reasons why the adoption of a green building is not yet considered in the construction of residential building in Oman. Because people believe that green building construction will be a little bit expensive compared to none or to those conventional building. And here we have the deficiency of adapting or constructing green building, or what are the main points that need to be considered when we want to construct a building and we can call it a green building. There are a number of criteria that need to be considered if you want your building to be green. And in this column, we have the state-of-art solution for that criteria. Here we have the energy consumption task and drivers inside the building. I have considered the residential building only in this case study because it's widely used, as you have seen in the previous slides. And here is the energy consumption in this typology of building. Sorry, in this typology of building. For an example, in villa, the consumption of energy more than Arabic house and the apartment. And the energy consumption scaled to the area, to the metric square of area. So no matter how big or small the building, the scale is unified for all those types. Looking at the daily energy demand profile and consumption in Oman, it's, as I mentioned earlier, the behavior of people inside the building will lead to the consumption of energy. If we look at building by itself, if we look at the building by itself, it will not consume energy if it is standing ideal and no one uses it. The way we use the building, the way it will consume energy. And this graph, in a study conducted by the Authority of Electricity Regulation, it shows you different profiles. One in the summer, in August, and one in November, when the temperature is slightly better, and one during Ramadan time at that year, because the life pattern of people will be changed during these three different periods. Similarly, this graph shows you here the consumption pattern of energy inside the building, when it is switched on, when it's switched off, when it's switched on with people inside the house, when it is switched off and no one, when it's switched on and there are people in the house. This is very important because these two graphs characterize the energy consumption of people in the country. And the research has covered more than 100 houses here in Oman, and we have conducted a number of questionnaires. And I remember one of the questions we asked the people, if you are going to the market for 1 hour or 2 hours shopping time, and you left some of your appliances, let's say the AC, on inside the house, will you decide to go back and close it or not? The answer was mainly not, because of the, as I mentioned earlier, the energy prices in the country is less, so that lead to the people may not consider the issue. Let me just show you here the energy consumption in the house, how it is delivered. How is the energy delivered to the house? We know the energy will come from a primary source, which is in our case is the generated electricity in the generation station. And then there will be conversion loss in that when you convert, we know all of us as engineers or scientists in this field, that when you convert energy from one form to another form, there will be a loss. Further, there will be lost in the energy when you are transferring this energy from one place to another place, until it's finally, it reaches to the home or the house. We call the energy comes from outside source, we call it supplied energy. And if there is any energy generated within the boundary of the house or the building, we call it inside energy or renewable energy. And the end user is the appliance and the equipment that we are using in our buildings. Here, this graph, I will go through it a little bit fast, but I hope that I will explain it enough. We have number of tasks in the house or in the building that consume energy. We classify them in these 7 categories. The first one is the HVAC, or the air conditioning system, or the system that we use to modify the internal climate of the building. And then we have the lighting, the watching, and the other activity, cookings, and all those activities. And for each task, there will be a number of devices using energy in that task, and the energy consumed by that task is the total energy delivered to that task divided by the efficiency of the appliances that we are using or the equipment that we are using. And then the total building total operating energy will be the summation of all those energy consumed in the whole building. And it will be accounted if we want to see the building energy index. We can divide it by the area. If we want to see the if we want to see it in a more way of rating to the user of the building, we need to add the occupant and the user at the building in order to come with accurate consumption comparison between building to another building. And if you remember initially when I talked about the CO2 emissions, I said it might not be fair, the scale that's used, because it is comparing the CO2 emissions to the total population of the country. But we have to do the same way. And this is out of the 100 houses studied by this research. This is the average annual electricity consumption profiles of Omani house. You can see it's very clearly where the energy mostly used. And in this diagram, it shows you that there is heat gain coming to the building will lead to in this month to have more increase in the energy used. Now, out of those 5 green buildings studied in the research and the 1 international, we come up with a number of design guideline requirements that when we want our building to be green, we have to go through this guideline. For an example, I will, because of the time concern, I will just go through them quickly, but I will explain some of them. The first one is the orientation of the building. If we orient the building in a different way, the heat gain will be changed, and that will lead to different need for air conditioning energy, and so on with the other guideline. This is the building we have here in our UTAS in Muscat, and it's called Greenest. The university signed an agreement with the electricity distribution company in the 14th of 2004. That agreement allow the university to connect this building or the photovoltaic system of this building to the main grids. And that was very important because most of the green building which use photovoltaic panels, sometimes they deliver more energy than what they need, so that more energy should not be wasted. It can be fed to the grid, and during the low energy production, this building can extract energy or electricity from the grid. Very interesting, when we come to the design of this building, we design it to be zero energy consumption. But during the operation, we have obtained that this building is positive energy consumption. What I mean by positive energy consumption, it is delivering energy more than it consumes. In fact, it deliver or can produce double the energy it's used. So there is a promising industry here for green building if it is considered. Normally, scientists believe that for 2 to 3 floors, it's easy to supply, especially in a climate like climate of Oman, to supply the whole inner building with photovoltaic panels in the top. But some countries, like in Singapore, the National University of Singapore, they have constructed 5 stories building, can operate only with photovoltaic without any external energy need. Yesterday, one of the presenters mentioned the service of the material and how the dust can be solved in the issue. Here, what we have when we constructed that building, this photo has been taken from Greenest, the building in Muscat, and I don't know how much is this image clear, but this white color in this hot water, solar hot water is full of dust. And this is after 2 weeks of cleaning. So our weather here in Oman is very dusty, and that's why we need to consider it. One of the issues that has been used in some of those green buildings, using the artificial lighting, reflection of the artificial lighting inside the building to provide lighting so that we will not need to use the artificial lights. One of those green buildings in Nizwa, they have used a cooling system, which consists of bond of water and a pump to pump air through this bond and supply it to the building to reduce the temperature. And this technique proved it's successful by reducing the temperature in the day of the test 4.6 degrees. This is the one I have mentioned right now, and this is the difference between the two temperature, the temperature of the air before entering to the system, and the temperature inside the building. So the air will come through a green roof to reduce its temperature. Then the pump will extract the air, will pass it through water bond, and then it will be supplied to the building and reduce its temperature. Now, if we are talking about 4 degrees centigrade, that means it might be the cut between the need to open the AC or to not to open the AC. And this is the energy efficiency measures we have obtained from all those buildings. We have categorized them here and list them, and we have mentioned remarks about them. For an example, the building shape will have an impact on on the heat gain from outside sources, similarly with the other energy efficiency measures. Because of the time concern, and I have quite a number of slides, I will go through this one. Now I will just explain for you the residential building energy template that has been delivered and designed by staff from UTAS, and it works in this manner. It uses Excel sheet, and Excel sheet is a powerful tool for calculation. Most of the rating system in the world, they use Excel for this. For an example, the BERL rating system in Abu Dhabi, they use Excel for their rating system for the building. Similarly, in Canada, RPEAT, the rating system RPEAT there, they are using also Excel as the engine for the calculation. It's simple to be used and accurate for the calculation. Back to our slides here. This is the way how it's operate. If you are using it for an old building or new building, you have to feed in the data. So the data will be fed into number of slides, and I will go through them one by one, and then at the end you will get the results. If you are happy about the results, then you will print the report. If you are not, you can repeat and start changing the parameters. Why do we need to do this? I will show you in the next slides. Here how it's work, and this is number of the slides inside the template. One of them very important is the orientation, as I have mentioned. So the user of this tool will have to enter the orientation from the north of each side of the building in order, and the calculation of and the spreadsheet will calculate the energy gain at that side, and similarly with other sides. Again, also, first of all, the user will need to fill in number of general information about the building. For an example, the area of the building, the location, the number of the users, and so on, because we have seen in one of the slides before that the number of users in the building will have an impact in the energy usage. The template at the end will rate the building according to the outcome we have obtained from the green building in Oman. Those 5 buildings we have looked at previously, they have an energy index. Energy index, the amount of energy consumed per square meter. And any building would like to see its energy index, we compare it to that one, and then the tool will show you how much you are compared to those green building. And by this, you can measure the degree of your green building. Because green building can be different from one place to another place, it can be different also in terms of the usage. Similarly here, all the data, electronics, hot water, the use of renewable inside the building, all the data, the pattern, how many person inside the building, at what time they will be available, similar to the study that we have seen earlier developed by the Electricity Authority. The data have to be inserted in those spreadsheets. And then before the end, how much renewable energy is used, if the building uses renewable energy or not. The data of those renewable energy also need to be fed inside this template. And then finally, the template will show you the energy consumption per month and will rate your building for you automatically. And behind the scene, the spreadsheet will do the calculation based on the data provided inside the spreadsheet for each day, for each week, for each month, for each year, and so on. What we did here, because it's a new tool that we just developed and it's still under testing, we have tested with one of the modeled house. We have calculated the energy, we have measured the energy, and we did the calculation by this tool, and we find that the difference is the difference will remain there. The difference, whenever you are doing modeling, the difference between the modeled and the actual will be there, because 100% modeling cannot be done. And this is similarly with the building in Singapore that I have mentioned about you. We asked the people who designed this building, what was the outcome of your building? And what's the difference, of the outcome of your building between the design stage and the actual? They said it's about 20 to 25. So it's similar to what we have already here. This is basically can be used in different way. This tool can be used for rating the buildings. It can be used even by any ordinary person who would like to see and the management of energy inside the building. It can be used also by the designers. It's mainly designed for the designer. Those people who will design the building, they need to quantify the amount of energy will be consumed on that building. Because right now, if you want to get a permit for a building, you don't have to show any data for your energy consumption. But if the Green Building Code implemented in the country, all the designers, they have to show to the concerned body the energy consumption management inside the building. So, yeah, this is basically the tool, and it can be used also for labeling system like this one, which is used in Tunisia to rate the building. If you look, here, in different way, you can label the building. In similar way, the labeling system in the other country is used. In Tunisia, in Europe, most the world, they have labeling system for the building, like the labeling system you have when you purchase any new tools, even a car. It shows you how much energy this car is using, and so on. This is finally what we come up after using this tool, after reviewing all the green building. This could be a suggested roadmap for the construction industry to shift from conventional kind of building to a green building. The roadmap will consist of vision. The vision will state at which time you are aiming to do so. It could be 2040. We put it as 2040 to be aligned with the vision, Oman Vision 2040. And then there will be a target area, and then there will be action. What action is required in order to achieve the vision in the target area, and then achievement, to measure the achievement at the end of your plan. This is mainly my presentation for today. I wish that I have delivered it in such a way that it was simple to all of you here. Despite of the short time slot that I have, I tried to manage to deliver it in an easy way. Thank you for your attention, and I will be available for a question later.
Thank you, Dr. Yahya, for the impressive talk. It will now be the turn of the table discussion. It's our honor to have again Mr. Wahid Al-Fazari, Sustainability Manager at Refineries Petroleum Industries, OQ, to lead this discussion, which will involve the three keynote speakers: Dr. Eni, Prof. Dr. Khalifa Al-Jabri, and Dr. Yahya Al-Shamsi. Please join Mr. Wahid on the stage.
Bismillah ar-Rahman ar-Rahim. So the language will be in English, but if required, we can change to Arabic. And let's have today, let's have more questions from the audience. So I won't be talking much, and they will be answering your questions. So please join me welcoming Dr. Annie Oko and Professor Khalifa Al-Jabri and Dr. Yahya Shamsi. First of all, very insightful talks, very informative. Thank you all. Let's start with Dr. Annie. Dr. Annie, you know that the uses of hydrogen is almost in every sector, including industry, refining, steel production, chemical, and sort of. And the way of transportation also differ, but you are talking about only one. You talked about the hydrogen carriers, but other method including pipeline transportation, high pressure vessels, and sort of. Based on the information given and your research, how you see the infrastructure of natural gas pipeline ready to transport the hydrogen? Is it ready, or comparing to the methodology you presented already?
Okay. Yeah. Yes. The idea of repurposing existing natural gas pipelines for hydrogen is something that is being considered in many parts of the world. But I think one of the things to keep in mind is that hydrogen, as I mentioned, embraces steel, depending on the transport pressure. So what is happening is that you can have a portion of the natural gas replaced. So in UK, there's been trial for adding around 20% of hydrogen to the existing natural gas that is being transported through these pipelines. But when you go to 100% hydrogen, then there is going to be significant impact on the infrastructure, as I've said. So a good portion of this will have to be completely upgraded and replaced with a different kind of material. Yeah.
Great.
And just and just to add that of course pipeline transport is often like within the country, but for like international transport, you still need shipping vessels to be able to do that.
Thank you. It's a great. It's the methodology itself of transportation and the hydrogen type is indeed a hunting ground for researchers like you and the audience as well, to see the capabilities and the results of different methodologies and hydrogen type as well. Thank you very much indeed. Professor Khalifa, you talk about the sustainable concrete, and we know that it's not just a tag on a product. It's involved a lot of things from the sourcing of the material itself, the manufacturing, and then the disposal and sort of. A manufacturer or an industry could tag that by tackling different aspects of the sustainability. But how do you see these sustainable construction materials? And I think you mentioned this, compared to the traditional ones, in terms of performance metrics such as durability, strength, and longevity.
Thank you, Wahid, for your question. This is a quite important question. As I mentioned in my presentation, we need to look at this materials as an opportunity, not as a burden, because most of people, they look at these materials as a burden. The use of these materials has proved to be effective in the construction industry. I will talk mainly with in the construction industry, and it has been used in different applications. The main problem with some of the research, some of the studies did not consider the whole aspects of the material. As I said, we need to carry out material characterization. We need to know the properties of the material. We need to assess the environmental impact. And therefore, it's very important that this material should be studied thoroughly. For example, until now, there is no specifications or code of practice for using steel slag, for example, or ferrochrome slag. But it's been used in other countries commercially. When we had this project with the Sohar Port and Free Zone, we formed a technical committee from different stakeholders, from the Ministry of Transportation, from the, at that time, the Ministry of Environment, now Environment Authority, from the Directorate General of Specifications, from the Ministry of Commerce, in order to, that this committee should be aware about what's going on. And also we took them in a visit to Finland and to UK to see the application of these materials in practice. So these materials are used, some of these materials have benefit. For example, when you use a steel slag, for example, we can reduce the subbase of the road, and therefore we save a lot of material. So first we need to make sure that the material can be used environmental friendly. Then we need to develop our own specifications. And also we need to find someone who has the ability or desire to use this material. People are reluctant when they hear the word waste. Oh, they say, okay, this is very dangerous. Now we had, not myself, but I think the office of the governor, he did an initiative to use ferrochrome slag in the paving of some, not roads, but car parks, yes, with the At-Tasnim and with the At-Taman, there's collaboration. And this is for free, so that the people, they get used to the concept of using this material.
Spot on. Wish you all the best in the endeavor. And we hopefully will see those material being used by the public, inshallah. Dr. Yahya, so we learned from yesterday and the plans of Oman that the building sector itself has no direct emissions, of course, but from, and I think you also mentioned this, from the usage of the energy. So it is, I believe 80% of the power demand based on the 2021 baseline of Oman. And that's almost 15% of Oman's overall emissions. So how do you think the introduction or the introducing of the Omani Green Building Code will change how much the energy building use and how much the CO2 they emit in Oman?
Thank you for this question. It's well known across the world that whenever you are using green building, the associated the energy use and its adverse associated effect will be reduced. That's clear and well known and proven. And we have seen in my presentation today that the green building constructed by a number of universities in Oman have proved this concept that the energy consumption can be reduced very dramatically. And but since we don't have the Omani code for green building, as probably all of us are aware here, no one will go for it for several reasons. Probably I haven't mentioned this in my presentation because of the time limit, but we know that people normally tend not to like the changes. This is one of the reasons. The other reason, the cost of the construction benefited. Third is the technology required. And not all those reasons may not be all of them are valid, but it have been taken in the people's mind now. For an example, the cost may not be more. You can build a green building with the same cost of conventional or ordinary building. So the mindset of people will need to be changed also. And the code, if it is implemented here, that will, I will not say it will force people, but it will orient people to go to in this direction, which will lead at the end of reduction of energy consumption and its associated adverse effects. However, there is one important point also with the green building that we need to consider. Green building by themselves may not be green also, if the people who are using are not green. And the meaning of green people here, the behavior of people, like the question I asked initially, will people pay attention to switch off lights when they are not in? Will people pay attention to use this kind of ambulance when we go to the market and purchase any home ambulances? People, in most cases, they don't look at the energy consumption of this equipment, home equipment. They more look at the prices. So this is what I mean by green building. The green code, yes, will lead to reduction on the energy consumption and CO2 emissions, but also human behavior and people behavior need to be also adjusted to suit this issue.
Thank you. Well said. Well said. Thank you. I totally agree. And we heard that from the latest information we have from the Ministry of Housing and Urban Planning that the Omani Building Code will be activated soon. And let's hope they tackle the greening of these buildings as well. And let me add this, that the energy efficiency and conservation program by the Authority of for Public Service Regulation, they addresses the energy efficiency in households or the housing, on communities and the industries. So they are looking into this as well. And let's hope that will drive the change of the community as well. So let's open the floor for a question from the audience.
Doctor, if you use the recycled material, is the cost similar to the traditional one?
Yes, it depends. You need to do life cost. This is a good question. We need to use the LCA analysis, life cost analysis. Sometimes it's not that, it is not cheap compared to the natural, the material from natural resources, since you need to transport this material. And therefore, it is very important before using of this material to carry out or to conduct life cost analysis, life cycle cost analysis. Sometimes the companies, they want to get rid of this waste material, and therefore they provide this waste material for you for free, since it is accumulated in large quantities. But if it is commercially available, yes, you need to carry out LCA analysis.
Please go on.
Thank you so much for our distinguished guests and the valuable information they provide in their presentations. Actually, I start from Dr. Ini. Doctor, I'm not very in the chemical engineering, but I have a general question. From the picture you showed about the initiatives now for transporting the hydrogen as ammonia, I saw many countries in the, let's say, cold weather places. there is any weather conditions related to the, let's say, hot weather like here in Oman, to the transportation of ammonia and anything that can be done particularly for such region. This is number one. And number two, what can be exclusively done here as research in the institutions in this region to help in these things. So I need the hint actually to open doors for my colleagues and the university to work in that, and how can be research in that field. So this is my question to Dr. Ini. To Professor Khalifa, I heard at the end of your previous answer about now there are kind of incentives from the governor office about reuse of the waste, between brackets, in the car parking and so on. So what are the incentives that can be given to the people to reuse these waste, between brackets? And also you mentioned in your presentation about illegal dumping for this kind of material. I'm very concerned about the immigration of heavy metals to the groundwater. So you know, the tectonic studies here in the region, it shows there is a trace even for heavy metals, for radioactive materials, and so on in Jabal al-Hajar. So by the mining, it might free these kind of elements, and it will immigrate to the groundwater. So how we take that into consideration if we reuse the waste, between brackets, material to the buildings and so on? Do we consider this kind of things? But because also the marble waste and so on, now they find a way in some architecture or even in tables at home and so on, they reuse it. There is any limitations, any considerations has to be investigated as well? This is my question to Professor Khalifa. Last but not least, to Dr. Yahya, now we see that there is climate change effects. Many heavy rains coming to Oman, and we suffer from that one now. Not suffer, but we face that challenges nowadays. So do you think that even considering the change in climate should be adopted in the building code as well? Because also we see nowadays some buildings, they are using this kind of glass in their front shield. We know that the thermal conductivity will increase the needs for HVAC. If we take into account, for instance, Oman through Age's museum, the design for it now, it reduces the need for lighting and all the things. Can we use same ideas to adopt it at homes and to reduce this demand for cooling for the buildings? The last question, yesterday we had a very informative presentation about the coating for the surfaces. What do you think about using this kind of materials for the coating, even in the paints? If we add a layer from such environmental friendly material to reduce or to limit the thermal conductivity, to cool down the buildings and so on. Thank you so much.
Do you want that, sir?
All right. Thank you so much for your question, Wasil. I think going back to why the European nations seems to be leading the way for hydrogen. To answer that very well, we need to understand why many people are interested in hydrogen. The truth is, with the conflict in Russia, more countries are embracing hydrogen because it appears that if they can completely develop hydrogen production, that it can help them become energy independent. So I believe that the political interest for different countries to be energy independent is one of the reasons why, for instance, especially European countries are very, very interested in developing hydrogen system. Coming to how the academia, the academic community in Oman, what they can do in terms of how Oman as a nation can benefit from all this. Oman is a country that I believe is, its energy export is one of the major source of revenue for the government, if I would say, all right? And in the future emerging energy ecosystem, where we expect that hydrogen is going to play a very significant role, that would mean that, for instance, Oman is going to be positioning itself such that it's able to continue to be at the forefront of energy export. And how that is going to happen is that, for instance, the existing oil and gas production system is going to be decarbonized, for instance, through carbon capture, so that the hydrogen that Oman is going to be produced is going to comply with what the international market wants. What that would mean for Oman is that if ammonia is going to be the means for transporting hydrogen, it means that Oman is going to build capacity in the area of transforming the hydrogen that you are producing to a suitable form, ammonia, for instance, where this can then be shipped to the various end-user countries that are importing energy from Oman. So for the academic community, there is lots of opportunity in the area of developing the various methods for hydrogen transport, not just ammonia. As I have mentioned in my presentation, there are other ways for transporting ammonia, and for transporting hydrogen, and most of them are still at very early stage developments. For people from chemistry background, for instance, or even chemical engineering, there are lots of potentials in metal organic frameworks development as a means for transporting hydrogen. Okay, so it's something to have a look at. Also, there are lots of interest in catalyst development. Most of the conversion methods involve the use of catalyst. And as I have mentioned, most of the catalysts that are currently in use are rare earth metal kind of materials, which are very expensive. So people from chemistry, from chemical engineering background, can be looking at how to develop new catalysts. I have just given you a snippet of how computational method is being used these days for catalyst development. It is an area that I am personally very passionate about, and very happy to jump on anybody that have interest to collaborate. And developing capacities in computational catalyst development, in catalyst synthesis, catalyst preparation, catalyst characterization, etc. So it's, there is a lot to be done in that area. And people from chemistry background, from physics background, like yourself, Wasil, from chemical engineering background, can all jump on different parts of this area. Thank you.
Yes, regarding the first question, actually the Minister of Commerce has issued a strategy for recycling industry in Oman. And within that strategy, there are some incentives that are given to the entities which is using the recycled materials. I can't remember all the incentives, but one of the incentives that if you are using a green material, waste material, you will be given the priority, for example, for the tender. The second also incentives is reducing the taxes on the companies, reducing the tariffs, and therefore this will will encourage the other stakeholders to use these materials. For the second question, it is difficult. For example, illegal dumping it is difficult to control. You need an effective tracking system, especially these dumping takes place for the demolition and construction wastes. And it is difficult to track unless you have an efficient system from the starting of demolition or the starting of the construction until the final process where you'll deliver the material up to the legal dumping site. Of course, for hazardous materials, for leaching into the ground or seeping into the ground, as I said, it's very, very important to carry out the environmental impact assessment of these materials. In order to control the leachate, you need to see whether this material has heavy metals, harmful heavy metals. You need to analyze the raw materials, and also you need to analyze the material after it's been used for the binder as a whole, because sometimes the binder will prevent the heavy metals from leaching into the ground. So there is codes and standards for this, and there is a lot of tests can be done in order to make sure that the material can be used safely. Thank you.
Thank you, Doctor, for your questions. You have mentioned very important point in regarding to the green code that need to be of the drivers for the need of the green code. You mentioned the climate change and its adverse, like the cyclone, which is happening and very frequently now compared to the previous era. During the last 20 years, probably 4 cyclones happened, those which are hit our country. Number of cyclones created in the oceans may be more than this, the frequent even more. In between, there are severe storms also are coming. And this is very clear as a result of the temperature rise of the oceans, because we know that when the surface temperature of the ocean rise up, the ocean will release this energy in terms of cyclone. The hot surface of the water will create more evaporation. This evaporation will create the cyclone. As more as it's happening, the process will keep repeating until it hit the ground. And this is very important. That's why, as you mentioned now, in the design concept of a building, no matter what are those buildings, we need to consider all the aspects. We need to design adaptive design, resilience design. Those things need to be considered now in the designing of the building. And those also will be controlled by the code itself. It's not enough only, as I mentioned, to have a green building that has photovoltaic on the top, or maybe heavy or large amount of insulation inside the building or inside the wall itself. Other aspects need to be considered, like what you have mentioned, the glazing or the glasses used in the building. Normally it's controlled by what we call it wall glazing ratio. This has to be controlled also. It shouldn't be kept open so that in order to control the heat gain. Though there are a number now of glazing or glasses used in the construction, they have high U value, so that means they are resisting the heat gain. But in the other word, if we want to look a full sustainable approach, the creating of this material will consume a lot of energy, and that energy will create adverse effect. So we need to look at the issue from perspective view, from all directions, in order to come up with a comprehensive solution for the whole issue. This is when we are talking about the design. It needs to be match the requirements. It needs to be adaptive. It can be sustained for the next era, because the weather change effects will take longer time now. The world is trying to limit the rise to 2-degree temperature. It's not reducing, to limit the rise up to that extent. Then it will start to reduce, and that that means the effect will continue with us with 50 years maybe, those effects until it's stable and comes down. So we need to consider this in all our designs. When you talk about the lighting, I have mentioned this, we need also in our designs to consider the natural lighting in all the designs we are making for whatever buildings. This is very important, especially in Oman. If you look at the weather condition in Oman, we have sky cover very limited. Most of the days through the year, we have the sun outside. So, and this sun provides us heat, and also it's provide us with lighting. So let's extract or do some advantage of this disadvantage, which people consider as disadvantage somehow, and to extract enough lighting inside the building. And this is very important. The last question, when you mentioned about the service and the paint need to be used in the building, the reflectivity of the paint is very important. So as much as the paint, especially for the external walls, will reflect the sun ray comes, that means it will reduce the heat gain. But again, for me as a person concerned about the sustainability, we are thinking on all directions, thinking in the way that this material will be used and the way this material will be produced. Again, this is very important. Probably all of you here heard about the giant project will be ongoing in Saudi Arabia, what they call it the line. A whole city will be covered by glass, by mirrors, in order to reflect all the heat comes. But how much amount of mirrors we will need and how we are going to produce this material, this is the key question. If we are really concerned about sustainability, we should not only look in one direction and we say that we are achieving. We have to consider the other adverse effect, either in producing this material or either in the way we operate, because the operation is very important. Those buildings will consume energy during the operation. I hope that I have answered your question, Dr. Wasil. I think you have asked 3 questions. Is that's it? Thank you. Because you select to give me 3 questions more than others. I don't know why.
Thank you, Doctor. Thank you. You touch base on a very important topic, climate resilience in terms of adaptation and mitigation, especially in the infrastructure resilience. Let's have one more question from Dr. Daniel, and we'll wrap it up after that.
Thank you very much to all 3 speakers for the very nice and insightful presentations. I really enjoyed. I'm just going to ask one question. I have a question for all 3 of you, because during my undergraduates, actually, I did a project on the stabilization and solidification of electric arc furnace dust, as well as slag. And my first project as postgraduate was in the chemical storage of hydrogen energy using iron sponges, so a different material. But my question is going to be today for Dr. Yahya, and it's regarding the buildings presentation that you have done. So I have noticed that most of the kind of guidelines and the kind of tests and buildings that you have been doing are kind of individual households, just one single house. However, we know that dense populated areas where we have tall buildings, they actually consume more energy, right? Because we have many more householders there. My question here is, if we as society, we have lost a little bit of memory, and my example here is we used to construct as like medinas, right? Like the markets, very narrow streets, tall buildings that give shade to other buildings, so that we reduce the kind of need for cooling technologies, right? So my point here is, have you considered these kind of earlier techniques to kind of build before, and also what are your thoughts for dense populated areas when you compare to the kind of individual household? Thank you.
Thank you, Doctor, for this question. Normally, when you are dealing with the society, and probably most of you are aware, it will be very hard to come with one solution suit everyone. This is very obvious and clear. But however, when we are doing any research work, and most of you, all of you here are researchers, we tend to group or classify things in order to put them in the right and then make our study on them. The society behavior will be changed. The area will be changed also from one place to another place. And that's why I mentioned it's not advisable that energy code or green building code to be imported from one place to be used to another. The best way to have effective green code is to be established based on the sustainability criteria in that place, which are the economic, society, and the environment. And the society behavior, as I mentioned, it can be changed from one place to another, and that is uncontrollable. Even when we are doing the analysis here and we are saying this is the energy profile for a typical Omani family. But is that happened all the time? It's not. It's changed from one time to another time, and that's what will make the variation in the outcome of the modeling. In our research, what we did here, we have studied 100 Omani households, and we look at the pattern, we look at their behavior, number of occupants, age also important, class, and I mean by class the category of people, income, because that also will change their behaviors. Many criteria will affect this, and based on that, we come up with some of those guidelines, which I have mentioned. Very unfortunately, we have around 15 guidelines point in my slide, but I didn't cover all of them, because covering all those 15 guidelines will need one full presentation alone. So it has been considered. Regarding your question about considering the ancient or the previous technique being used by our incasters, by people before, that definitely been considered here. And people in this area, especially in the Al-Batna coast, before the era of 70s, they used to construct their houses facing the east. And that for a reason, to face the sea breeze. The wind will be generated between the night and day and between the sea and the mountain, and will create that breeze which will help to cool the building. This is also included in the criteria. The orientation of the building. I have mentioned the orientation of the building because it's very important and it will affect the heat gain of the building itself. So it has been included in the guideline of that one. We have studied also the people of Oman in the past, what they used to do. How do they construct their building? How do they make use of the available material? For an example, most of the building in the interior of Oman, they put the windows at very high elevation for obvious reason, to provide daylight and also to provide some cooling, and then it will not heat up the floor in the same time. So there are a number of techniques being used previously. We consider them. But to be very honest with you in this, now what's happening is the society behavior is changing. Mood is changing. Here in Oman, before 70s, there are no air conditioning system, and people used to live and happily. So, but now, who can live even in winter without AC? Like what I mentioned, now we are inside this building. This building uses intensive amount of energy for cooling itself. Maybe one of the reasons because not considering making use of the outside air, which at this time pleasant to be. So those points are will be considered in the code, and it will need to be considered in the design phase of any building. Thank you. Have I answered your question? Thank you, Professor.
I think we have one more comment from Professor Halil.
Yes, I have a question to Annie. How do you see the long-term benefit of using green hydrogen? Actually, I am worried from some reports. I think about 2 months ago, I heard that Norway has stopped the projects in green hydrogen, and they said Norway said it has no future benefit. And also, a week ago, there's another study which has been published saying there is no future for the use of green hydrogen. Now, Oman has invested billions of dollars on this technology, And also, it is going to spend more. So what do you think about this?
Okay. Honestly, green hydrogen is very problematic, but I will try my best to try to answer your question. Now, part of the things that makes green hydrogen very problematic is that it uses a lot of fresh water. That's one. Before you even begin to talk about the energy requirement, it uses a lot of fresh water. Direct seawater electrolysis is not developed yet. It's still in development. If we had gotten to the point where we can directly electrolyze seawater, maybe the story will be very different. And to desalinate seawater and then use that for electrolysis even makes things a lot more complicated for a country like Oman that have a massive resources for seawater and not so much for fresh water. This is very problematic. Even though you have a lot of sun, for instance, that means that if the idea is that you are going to be desalinating seawater and then producing green hydrogen with it, that will make it very, very challenging, very, very expensive. Okay. So, but generally in the UK and many Western countries, while different governments continues to invest in developing modernizing electrolysis technologies and looking to drive down the cost. The cost of producing hydrogen through electrolysis is currently at around $4 for a kg of hydrogen. And to be very competitive, the target is that that amount needs to come down to around $2.2 for a kg of hydrogen. What it means is that there is still a long way off into the future before green hydrogen can be adopted more universally. What is not in debate, though, is that we can also use the existing natural gas resources to produce blue hydrogen. And in the UK, by 2050, the hydrogen that they are expecting to be using is definitely going to be dominated by blue hydrogen and not green hydrogen. So green hydrogen probably do have a future, but that is probably going to be far into the future. As at 2050, by 2050, the estimate is that in the UK, for instance, green hydrogen will not be contributing more than 20% of the hydrogen that they will be using. So it will be blue hydrogen. So Oman is still going to be at the advantage point because of the vast natural gas resources that the country has got. Okay, and if the green hydrogen market improves, I believe that the investment is not going to be wasted. Norway have a lot of renewable energy because most of their electricity comes from hydro. I believe that Norway can do anything that they want to do because they already have a lot of renewable energy, you know. Yeah, thank you.
Thank you. Just to emphasize that the blue hydrogen is like the gray hydrogen, but using carbon capture as well techniques. It's the technology that make it expensive. But we do have one promising project here in Oman, I think started by Shell company. With that, we come to the conclusion of our session. Very informative, and thankful for the panelists. Again, thank you, Dr. Ani Oko, Professor Khalifa Al-Jabri, and Dr. Yahya Shamsi for your insightful comments and presentation. Thank you very much.
Prof. Dr. Khalifa and Dr. Yahya for the enriched discussion. With that, I would like to invite on stage the Honorable Dr. Hanif Al-Qasmi, Assistant Vice Chancellor for UTAS Suhar, and Dr. Naktal Al-Kharousi, Deputy of the Assistant Vice Chancellor for Academic Affairs at UTAS Suhar, to come forward and honor our distinguished keynote and invited speakers. To start with, Prof. Dr. Khalifa Al-Jabri, Department of Civil and Architectural Engineering, Sultan Qaboos University. Dr. Mus'ab Al-Rawi, Director of ISISCO Research Chair for AI Ethics, UTAS. Unfortunately, for some circumstances, he couldn't attend today. Next is Ms. Ahlam Al-Kharousi, Marine Science Center, Ministry of Agriculture, Fisheries, and Water Resources. Her speech will be this afternoon at 2 p.m. in Suhar Ballroom, titled Monitoring Biotoxins in Omani Waters. Finally, Ms. Muna At-Tarshi, Environment Authority, Oman. Thank you, Dr. Hanifa, Dr. Naktal. Our valuable guests, I would invite you to our second item on our agenda, the poster session now. Enjoy the coffee break while watching our posters. Thank you. اوكي، انا كاتبه الاول الثاني الثالث. اوكي اوكي ان شاء الله. No. كل حين تزيدوني شيء وش members of this conference. You have had long 2 days and have participated actively in this conference. And by this, the second International Conference on Environmental Sciences and Engineering for Sustainable Development comes to an end. Before wrapping up, here I'm listing the conference recommendations. So the conference recommendations: to adopt developing green building code considering carbon neutrality and impact of global warming on weather conditions, scientific consolidation of the Oman Vision 2040 goals and contributing to directing research and education to achieve the Sustainable Development Goals, integrating advanced technologies such as AI and IoT into environmental issues such as achieving net zero carbon, promoting and strengthening the society and organizations to play their role in achieving sustainable development goals, and finally, benefiting from engineering fundamentals and linking them to industrial and environmental applications to find solutions that serve the conference objectives and the Oman Vision 2040 goals. Now, I would invite the Honorable Dr. Hanif Al-Qasmi, Dr. Naktil Al-Kharousi, to give the awards to the best presented papers and best posters. We will start with the best posters. Third place goes to Isra Al-Badi, Deen Al-Isai, Asia Al-Khambashi, Al-Bara Al-Rasbi, and Sulaiman Al-Hanai from University of Technology and Applied Sciences, Sohar. Supervisor? Second place goes to Maria Rajesh, Anthony Amaladas, Ashwaq Al-Balushi, Layali Al-Shidi, Malad Al-Badi, and Maryam Al-Akhzami from University of Technology and Applied Sciences, Shinas. And congratulations to the first place goes to Manar Al-Attar, Anfal Shizawi, and Tahra Jafari from National University of Sciences and Technology. Moving to the best papers, presented papers. Third place. Okay. Third place of the best presented papers goes to Jayakaran, Krishna, and Sivamani from University of Technology and Applied Sciences, Salalah.
This is online. Yeah, this is online presentation.
Second place goes to our colleague, Dr. Muhammad Mayhoub from University of Technology and Applied Sciences, Sohar. First place, Dr. Geeta Devi and Noor Al-Belushi from National University of Sciences and Technology. Thank you. Now I leave the floor to Dr. Wasil Hashim, Head of Engineering Department at University of Technology and Applied Sciences, Sohar, to close this ceremony.
Assalamu alaikum wa rahmatullahi wa barakatuh. Good afternoon, everyone. And actually, I'm very pleased to stand in front of you to thank every one of you for being present here for today and yesterday. It was our pleasure to have all of you in this gathering, and I hope it addresses the objectives out of this conference. I would like to thank His Excellency Professor Mahad Bawain, the patron of the conference, who agreed to patron this conference, and also to His Excellency Dr. Saeed Al-Ribai, the Vice Chancellor of the university, who really directed us a lot to deliver this conference and to organize the conference. And I would like to thank also the Honorable Dr. Hanifa Al-Qasmi, who worked very close with us to organize this conference. And I would like to thank everyone here, and also I would like to thank the people at the University of Technology and Applied Sciences, Sohar. It's not all engineering department. I know for some people I can see how tired they are. They worked hard during last nights and weeks actually, and this work to organize these conferences started in March 2022. The next day, to close the first conference, first version of this conference, next day we worked to prepare for this version. So by the end of this session, I hope all your recommendations, as His Excellency yesterday stressed that he will work and directed all the team to implement the outcomes of this conference. And inshallah, I'm very sure, as the previous recommendations of the previous cycle was really well addressed, I hope it will be the same for this time. At the end, we have some sponsors and we have some people behind the stage. No one knows about them. I know the sponsors are here, starting from OQ, the golden sponsor for this event, Sohar, Free Zone and Port. They also co-gold sponsor for this event, Bank Muscat, Orak, and MBO. They are sponsors for this event. But we have really people, I don't know, I have a problem to express my thank and gratitude to them. I don't find the suitable words actually to say thank you. The team is standing here, our colleagues from Shinas, UTAS Shinas, they really worked hard for live streaming, for all technical aspects, for the presentations and so on. So thank you very much. Thank you is not enough to say thank you for you. Jazakumullah khair. So at the end, inshallah, I hope the conference was a good opportunity for you to share knowledge. And also, it is a great pleasure to have Dr. Dani from Edinburgh and Dr. Eni from Newcastle. And we had Professor Khalifa Al-Jabri and Mr. Al-Rumhi from Environmental Authority, and Dr. Yahya Al-Shamsi, the Dean of College of Engineering. Those are our plenary speakers. They really helped us with their knowledge. They shared their knowledge. Thank you so much. Hope to see you in upcoming events, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.